Welcome back to the deep dive. Today, we're changing lanes, literally. We're going to talk about those massive machines that share our roads construction vehicles. You know, a bulldozer on a highway project, a dump truck in town. These things instantly turn any road into a high-risk zone. We're talking about just immense mass, really slow movement, and a whole different set of physics.
That's it, exactly. And that's our mission today. We want to go beyond just the usual slowdown signs.
Yeah.
Our sources get into the technical why of it all, why these vehicles are so different from regular traffic, why their blind spots are just enormous, and what specific dangers they pose to the operator and, more importantly, to you.
Right. We've got data on their unique physical limits, the main causes of accidents, and the official safety measures the industry has to follow. So by breaking this all down, you'll be able to better predict their movements and hopefully seriously reduce your risk. Let's start with the pure physics of it. The biggest difference has to be the mass, right? So how does that one characteristic, just the sheer weight, create such a different hazard profile from even, say, a large commercial truck?
Oh, it all comes back to physics. Specifically, inertia. I mean, a fully loaded dump truck can weigh 80,000 pounds or even more. And our sources show that this weight immediately dictates two critical things: its speed and its stopping power.
Okay, so they travel slower, which is obvious. But why does that speed difference create such a risk for rear-end collisions, especially on a normal highway?
It's that speed differential. It's huge. If you're doing, say, 55 miles per hour and a heavy hauler is limited to 40 because of its load, that's a 15-mile-per-hour gap you have to close, and you have to recognize it fast. If you don't, the collision risk just skyrockets. That's why you see things like escort vehicles or advanced signage. They're designed to give your brain time to catch up.
And connecting that directly to inertia, what are we talking about for braking distance? How much longer does it take one of these to stop compared to, my SUV?
The difference is massive, and this is something every driver needs to internalize. Because of that weight, even with advanced air brakes, the momentum is just incredible. A passenger car might stop from 60 miles per hour in, 130, 150 feet? A heavy construction vehicle can easily need 250 feet, maybe more. So the rule for you has to be defensive driving. Just assume they cannot stop quickly, because they can't.
And it's not just about stopping, right? Their whole operational envelope is different. They're not built for agility.
Not at all. And that's where maneuverability comes in. Wide turns are, well, an understatement. To make a right turn, a large vehicle has to swing out left first. It needs that extra radius so its rear wheels don't just climb the curb or take out a sign. If you try to squeeze past on the inside while it's doing that, you are putting yourself in a really dangerous spot.
And then there's the risk of the load itself. We've all seen gravel spill, but what are the actual rules for preventing that?
The protocols are very strict. And it's not just gravel. It can be rocks, concrete, you name it. The load has to be secured. That means stacking material below the sidewalls, and for loose stuff like sand, using heavy-duty tarps. When debris falls, it can cause immediate chaos, broken windshields, blown tires, people swerving. It's a recipe for a multi-car pileup. And a huge number of accidents happen when the vehicle's moving at its slowest, or even backwards.
Reversing. I can only imagine how limited the visibility is.
It's terrible. Reversing is a major cause of accidents because the operator can see almost nothing directly behind them. The engine housing, the cab, the load bed, it all blocks the view. So the industry mandates layers of safety. You have the loud backup alarms, the beep, 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 we all know. You have cameras, and most importantly, you're supposed to have a spotter on the ground. The operator can't move backward without one. If you're near a work site, just assume a reversing vehicle does not see you.
That leads us perfectly into the visibility issue, which is probably the biggest frustration for drivers. Why are the blind spots on these things so huge?
It's really a function of the design. The cab has to be high up so the operator can see over the machine's own equipment, the bucket, the blade, whatever. But that height and the size of the vehicle body creates these massive blind spots all around. For some of the big haulers, our sources say the blind spot in front can extend to 20 feet.
20 feet? Wow, so a whole car could just disappear?
A whole car, yeah. That's why the old saying, if you can't see the operator's mirrors, they can't see you, is so critical. And it's the same on the sides and in the back. The blind spot can stretch out 30, maybe 40 feet. So the industry tries to compensate with, wide-angle mirrors, mandatory spotters, and now they're using more sensor systems with radar to alert the operator.
Let's touch on something people see every day but maybe don't think about. The color. Why are they all that specific safety yellow?
It's actually a fascinating mix of science and psychology. Yellow is one of the most visible colors to the human eye. It has this amazing contrast against the typical background of a work site: dirt, asphalt, concrete just pops, so it stays visible even in bad light, like dawn or in fog.
So it's pure visibility.
That, and psychology. We're conditioned to associate yellow with caution. It puts your brain on alert, and standardizing it is just efficient. A driver sees a big yellow machine. They don't need to know what it is. They just know. Danger. Slow down.
I wonder, though, if everything on the site is yellow, the bulldozers, the barriers, the vests, doesn't it kind of lose its impact? Like stimulus fatigue?
That's a great point, and safety experts do talk about that. It might lose some of its punch on the worksite for the crew.
Yeah.
But for you, the driver passing by, that contrast with the normal road environment is still incredibly effective. It helps you identify the hazards quickly.
We should also touch on the sheer variety here. We say construction vehicle, but that's a huge category.
It really is, and knowing what the machine does tells you what hazard to look out for. Take a dump truck. It's dangerous when it's loaded because of its braking distance, sure. But it can also be dangerous when it's empty because it's less stable and can stop much faster than you'd think.
And then you have the digging machines.
Right, the excavators. They're defined by that huge arm and their ability to rotate 360 degrees. The danger there is the swing radius of that counterweight at the back. It could swing out over a lane of traffic unexpectedly.
What about something like a motor grader, the ones that level the road?
The motor grader has that extremely long blade underneath it. That blade it can stick out several feet wider than the vehicle's wheels. If you try to pass too close, you risk scraping your car right along that blade. You need to give it a lot of sideways room. And then you have bulldozers pushing huge piles of dirt that can completely block the operator's view, or compactors, those giant rollers, which need a ton of room to slow down. Recognizing the machine helps you anticipate its next move.
Okay, let's shift gears. We've talked about the risks. What about the solutions? What does the industry itself do to manage all this?
The system is built on 3 pillars: regulation, training, and maintenance. So on the regulation side, operators need specialized licenses. It's often more than a standard commercial license. And if a vehicle is oversized, it needs special permits that dictate exactly which roads it can use and when.
So it's not just about the driver's skill, it's about planning the route itself.
Exactly. And vehicles have to meet really strict safety standards like roll level protection. The enforcement comes from mandatory inspections. Before a machine even starts its engine for the day, the operator has to do a walk-around, checking everything from tires to hydraulics.
And that standard can only be met if the training and upkeep are constant.
Correct. Training never really stops. Operators have to get ongoing education on new tech and safety practices. And on the mechanical side, preventive maintenance is everything. Brakes, steering, warning systems, they get checked way more often than on a regular car because the stress on the parts is so much higher.
So with all these rules in place, where do things go wrong? What's the weakest link that leads to an accident?
Well, this is where the human element comes in. A huge number of accidents come down to operator error, and very often fatigue. We see accidents from distractions like a phone or just impaired judgment from working incredibly long hours without proper breaks.
That fatigue point is scary given the stakes.
It is. Construction has tight deadlines, so there's always pressure to push it. But our sources are clear. Fatigue destroys reaction time and depth perception. And beyond the operator, mechanical failures are still a big factor. This usually traces back to poor maintenance, skipped inspections, worn-out brake parts, that sort of thing.
I'm guessing improper load handling is another big one for rollovers.
Precisely. If a truck is overloaded or the weight is all on one side, it raises the center of gravity. That makes it incredibly unstable, especially in a turn or on uneven ground. It's a recipe for a catastrophic loss of control.
And on a busy site, communication has to be key.
Oh, absolutely. A communication breakdown can be disastrous. Misunderstood signals between a spotter and an operator, or a vehicle merging into traffic without proper warning. Flawless coordination is required.
Okay, for our last segment, let's bring it all back to you, the listener driving on the road. What specific dangers should you expect when you enter a construction zone?
You need to anticipate 3 things. 1, your visibility is going to be reduced. There's dust, there are barriers, there's equipment everywhere. 2, the road itself is going to change unexpectedly. Lanes shift, narrow, or just end. And 3, the construction vehicles themselves are going to move in unpredictable ways, especially entering and exiting the flow of traffic at very low speeds.
So we need some hard and fast rules here. What are the essential things to do?
The foundation is just distance and patience. You have to maintain a safe following distance. We'd recommend a 4-second rule behind heavy equipment, not the usual 2 seconds. That gives you time to react. And don't tailgate, don't honk, just expect them to stop and start a lot.
What about passing? What's the key rule there?
You have to anticipate those wide turns. If a truck signals right but drifts left, It's not a mistake. It's a setup for the turn. Never ever try to squeeze by. Just wait.
And there's one side you should never pass on, right?
That is the crucial rule. Do not pass on the right. The blind spots are almost always significantly larger on the right side of the vehicle. The cab is on the left. The engine housing is often on the right. If you go up the right side, you are in a guaranteed blind spot. Always pass on the left, and only when it's safe and legal.
And finally, right of way.
Yes, just yield. Give them the right of way. These vehicles are slow and clumsy. If one is trying to merge, let it in. Your commute time is not as important as preventing an accident. The operator is already dealing with limited vision and a massive machine. Don't make their job harder.
Ultimately, it all boils down to being an engaged driver. Slow down, put the phone away, obey the signs, signal your intentions early, and just focus on staying visible to the operator. So we've really mapped out this complex situation, the vehicle limitations like weight and visibility, and the strict safety rules designed to manage those risks.
Right. And this deep dive really shows that safety is a shared responsibility. It's on the worksite, but it's also on every single driver to be aware of how these machines operate and what their limits are. Understanding that a truck has to swing wide is the key to avoiding a collision.
And to leave you with something to think about, our sources kept emphasizing how critical it is to manage operator fatigue with reasonable working hours and regular breaks.
Right.
So, given that so many accidents are caused by these human factors, how can we as a society, as employers, ensure that the intense pressure of construction deadlines doesn't end up overriding the very safety rules designed to save lives? That trade-off between speed and safety is a decision being made every single day.
Please like, subscribe, and get notified.